Speed, time and distance. In this lesson, we will learn about the relationship between speed, time and distance. The relationship between distance covered at a particular speed in certain amount of time is speed is equal to distance by time. The same formula for time and distance become time is equal to distance by speed and distance is equal to speed into time. Distance is usually measured in meters, kilometers or miles. Time is measured in hours, minutes or seconds, and speed is measured in meters per second or kilometers per hour or miles per hour. Note that to convert speed of an object from kilometers per hour to meters per second, multiply the speed by 5 by 18. To convert speed of an object from meters per second to kilometers per hour, multiply the speed by 18 by 5. Average speed. It is the total distance covered to the total time of the journey. It is given by if a certain distance covered with a speed of x kilometers per hour and another equal distance with a speed of y kilometer per hour, then the average speed of the whole journey is the harmonic mean of the two speeds given by the formula shown on the screen. If three equal distances are covered by three different speeds x, y and z kilometers per hour respectively, then average speed for the whole journey is given by the formula shown on the screen. If a certain distance is covered at x kilometer per hour and another distance is covered at y kilometer per hour, but time intervals of both journeys being the same, the average speed of the whole journey is given by x plus y whole divided by 2. If the ratio of the speeds a and b is x is to y, then the ratio of time taken by them to cover the same distance is relative speed. If two bodies are moving in the same direction at x kilometer per hour and y kilometer per hour, where x is greater than y, then their relative speed is given by x minus y. If two bodies are moving in opposite direction at x kilometer per hour and y kilometer per hour, then their relative speed is given by x plus y. General rules. Rule number 1. Train versus stationary object of no length. Time taken by a train of length L meters to pass a stationary object such as a pole, standing man or a building is equal to the time taken by the train to cover L meters. Here, speed of the train is equal to length of the train by time taken to cross the stationary object. Rule number 2. Train versus stationary object of certain length. Time taken by the train of length L meters to pass a stationary object of length A meters, such as another standing train, bridge or railway platform, is equal to the time taken by the train to cover L plus A meters. Here, speed of the train is equal to length of the train plus length of the stationary object by time taken to cross the stationary object. Rule number 3. Train versus moving object of no length. Time taken by the train of L meters to pass a moving man is equal to the time taken by the train to cover L meters. When the train and the man move in the same direction with speeds of x meters per second and y meters per second respectively, then x minus y is equal to length of the train by time taken to cross each other. When the train and man move in opposite directions with speed of x meters per second and y meters per second, then x plus y is equal to length of the train by time taken to cross each other. Rule number 4. Train versus moving object of certain length. Let's consider a situation where train number 1 crosses train number 2. When the two trains move in the same direction with speeds x meters per second and y meters per second, then x minus y is equal to length of train 1 plus length of train 2 by time taken to cross each other. When the two trains move in opposite direction with speeds x meters per second and y meters per second, then x plus y is equal to length of train 1 plus length of train 2 by time taken to cross each other. Rule number 5. If two trains start at the same time from point A and B towards each other, and after crossing they take A and B seconds in reaching B and A respectively, then A speed is to B speed is given by square root of B is to square root of A. Let's go through some rules which will help in solving problems related to boats and streams. When an object is moving in the direction in which water in the stream is flowing, then the object is said to be moving downstream. When an object is moving against the direction in which the water is moving in the stream, then the object is said to be moving upstream. When an object is moving in water where there is no motion of water, the object can move in any direction with a uniform speed. Then, the object is said to be moving in still water. On these grounds, if speed of the boat in still water is x kilometers per hour and speed of the stream is y kilometers per hour, then speed of the boat with the stream is given by x plus y, and speed of the boat against the stream is given by x minus y. When the boat is moving downstreams, the speed of the water aids the speed of the boat, and when the boat is moving upstream, the speed of the water reduces the speed of the boat. If the speed downstream is a kilometers per hour and the speed upstream is b kilometers per hour, then speed in still water is given by half of a plus b, and the rate of the stream is given by half of a minus b. Here are some rules which will help in solving circular tracks. When two people are running around a circular track, starting at the same point and at the same time, then whenever the two people meet, the person with a greater speed covers one round more than the person moving with a lesser speed. When two people with speeds of x km per hour and y km per hour start at the same time and from the same point in the same direction around a circular track of circumference c kilometers, then the time taken to meet for the first time anywhere on the track is given by c divided by x minus y, and the time taken to meet for the first time at the starting point is given by LCM of c by x and c by y. When two people with speeds of x km per hour and y km per hour respectively start at the same time and from the same point but in opposite direction around a circular track of circumference c km, then the time taken to meet for the first time anywhere on the track is given by c divided by x plus y, and the time taken to meet for the first time at the starting point is given by LCM of c by x and c by y. Let's go through some solved examples. A man covers half of his journey at 12 km per hour and the remaining half at 36 km per hour. Find his average speed. Solution: the average speed can be calculated using the formula shown on the screen. Solving the equation, we get the average speed as 18 km per hour. 150-meter long train is running at 36 km per hour. In how much time will it cross an electric pole? Solution: The speed of the train can be calculated to be 10 meters per second by using the relationship between train and electric pole. And the time taken by the train to cross the electric pole is derived to be 15 seconds. A man rows 50 kilometers downstream and 40 kilometers upstream, taking 10 hours each time. What is the man's speed in still water and rate of current? Solution: the speed downstream can be calculated to be 5 kilometers per hour by using the relation between speed, time and distance. Similarly, the speed upstream is calculated to be 4 kilometers per hour. By using the speed upstream and speed downstream, the rate of current is calculated to be half kilometers per hour. And the man's speed in still water can be calculated to be 9 by 2, which is 4.5 kilometers per hour. A and B start simultaneously from a certain point in east and west directions on cycles. The speed of A is 30 km per hour and that of B is 40 km per hour. What is the distance between A and B after 24 minutes? Solution: the distance between A and B after 24 minutes can be calculated by adding their individual distances from the start point. Using the relation between speed, time and distance, the distance between A and B after 24 minutes is found out to be 28 kilometers.